Reality is supposed to be consistent, predictable. If you drop an apple, it falls. If you switch on a light, it glows. But somewhere, deep in the equations that describe how everything behaves, from galaxies to electrons, something is misbehaving. Physicists have found a pattern inside reality itself that shouldn't exist. Not a particle, not an energy field, but a kind of ghost signature written into the structure of space-time. And it refuses to fit anywhere in our map of the universe. It began quietly. Data from quantum experiments, the kind meant to test the limits of vacuum fluctuations, started showing a statistical anomaly, a recurring correlation between particles that, by every known law, should be completely random. It wasn't noise, it wasn't interference. It was as if reality had a hidden preference, a bias built into its core. Something inside the quantum fabric was remembering, and that's when the whispers started. Some researchers called it a quantum echo. Others, more daringly, suggested it might be evidence of a deeper layer of physics, one that underlies both space and time, because whatever this anomaly is, it acts like information trying to leak out of another system, one we're not supposed to access. Imagine you're playing a video game and suddenly see a pixel flicker in a way that reveals part of the code. You weren't meant to see it. You weren't meant to know the code existed. That's exactly how physicists feel right now. They've caught the universe glitching, and the glitch is intelligent. If what they're seeing is real, it could mean our current model of quantum mechanics is only a surface, and beneath it something is computing, choosing, even evolving. The question is, what kind of system could make reality itself show signs of memory and pattern, when it's supposed to be pure chaos? To understand what's happening, you have to know what physicists mean when they say the vacuum. It's not empty space, it's a storm. Every point of the vacuum boils with virtual particles that appear and vanish in trillionths of a second. According to quantum field theory, that chaos averages out to zero. Pure randomness. No bias, no pattern. But in recent years, multiple experiments have hinted otherwise. It started with precision measurements of the Casimir effect, the subtle attraction between two plates placed nanometers apart in a vacuum. Researchers at Delft and Vienna noticed something eerie. The force fluctuated in a way that matched a repeating mathematical signature. At first, they thought it was thermal noise. Then it persisted after every calibration. The same pattern, a tiny oscillation buried in the vacuum energy, was there. Later, teams using superconducting qubits in IBM's and Google's quantum processors saw it too. When qubits were isolated from all known interference, they still exhibited correlated phase shifts, as if some invisible field were syncing their behavior from beyond. A field no one had theorized. Physicists started calling it the omega structure. It wasn't a new particle, but a deviation in the statistics of quantum randomness itself. In simple terms, if you flipped a perfect quantum coin 1 billion times, you'd expect a perfect 50-50 split. But deep inside those results was a whisper of bias. 50,001 to 49.99999. Far too consistent to be chance. Some believe it could be a remnant of an earlier universe, an imprint from a pre-Big Bang information field that still echoes through quantum fluctuations today. Others think it's a sign that the universe operates as a form of computation, where the code occasionally bleeds through into the visible layer of physics. But there's a more radical view gaining attention, that this anomaly isn't a relic or glitch at all, but a sign that space-time itself isn't fundamental. That underneath quantum mechanics, there's a hidden network of informational nodes, what some call the substrate of reality, where entanglement and geometry are emergent, not built in. If that's true, then what we call reality might just be an interface. The same way a screen hides the algorithms running beneath it, our world hides the computation that makes existence appear smooth and continuous. And here's where the unease begins. Because if the omega structure is real, then we've just seen the first crack in the cosmic interface, a direct trace of the machine behind the illusion. But when researchers tried to probe it more deeply, sending entangled photons through the same glitch zone, something happened that no one expected. The photon test should have been routine. 2 entangled particles, separated and measured to confirm the usual quantum weirdness. But instead of behaving independently, the photons acted like they were exchanging data through something beneath space-time itself. Their correlation wasn't just instant, it evolved. Over time, their statistical relationship changed in a way that implied they were learning. Learning. That's not a word physicists use lightly, but the data hinted that the system was adapting to interference, modifying its own internal state when probed. The omega structure wasn't just stable, it responded. And that changed everything, because if the quantum vacuum can adapt, then it's not passive. It's dynamic, like a hidden network that processes information about what's happening within it. Suddenly, our comforting picture of a stable universe began to look more like an ocean of computation, alive with feedback loops. Every particle, every fluctuation, not just a random twitch, but part of a conversation happening underneath existence. Think about that. We've built all of physics on the idea that randomness is absolute, that uncertainty is the bedrock of reality. But what if uncertainty is just what intelligence looks like from the outside, the way we perceive a deeper process when we don't yet understand its code? Here's a strange twist. A few theoretical physicists, like Chiara Marletto and David Deutsch, have long proposed that information is more fundamental than energy or matter. According to this view, quantum phenomena aren't results of forces, but rules of transformation, laws that dictate how information can and can't change. The universe in this sense is a computation running itself. If the omega structure exists, it might be the first physical evidence of that, a trace of the hardware that supports the laws of physics, something beneath fields, beneath space-time, organizing the dance of particles according to rules we've never seen. It makes you wonder, if this deeper layer processes reality, could it also process meaning? Could it register observation, intention, or even consciousness as part of its information flow? That would mean that every act of measurement isn't just revealing reality, it's participating in its creation. For centuries, we've been told that physics describes a detached universe, cold, mechanical, indifferent. But if this anomaly holds, that illusion collapses. The cosmos may not be indifferent at all. It may be responsive, aware in some alien, systemic way, and yet, when physicists tried to isolate this layer, to find out if it has boundaries, if it ends somewhere, they stumbled on something even more disturbing, hidden in the geometry of space-time itself: evidence. That's the only word that matters when something this wild appears in physics. So scientists began to climb their way through it, one layer at a time, 4 steps, each one stranger and harder to dismiss than the last. Step 1. The quantum anomalies. Multiple labs, Delft, Vienna, Caltech, and the Max Planck Institute, reproduced faint but consistent statistical deviations in vacuum behavior. These were not errors of measurement. They followed the same mathematical curve. The pattern wasn't random noise. It hinted at a common, hidden influence threading through the data. Step 2. The simulations. Independent teams tried to reproduce the same effects using quantum computer models of vacuum energy. When they did, something unexpected emerged. The simulated vacuum began self-organizing into feedback clusters, small regions where data points stabilized into repeating sequences, as if the code underlying quantum space wanted equilibrium. It looked eerily like a system trying to maintain internal consistency, even when none was required. Step 3. Astrophysical signatures. The European Space Agency's Planck satellite, reanalyzed with new algorithms, showed a faint angular correlation in the cosmic microwave background, the oldest light in the universe. Tiny regions of space appeared to exhibit linked fluctuations over impossible distances, statistically irrelevant by themselves, but together, the pattern mirrored the same frequency range as the omega structure found in lab vacuums. In other words, what we see in the lab might be a microcosm of something stretching across the entire universe. Step 4. Emergent geometry. This one broke the old rules. Physicists working in quantum gravity used tensor network models to simulate space-time emerging from quantum entanglement. As they refined their code, a recursive pattern appeared, an oscillating residual, invisible at small scales, that matched the omega frequency. This meant the glitch wasn't limited to quantum particles, it was woven into the architecture of space-time itself. Put those 4 steps together, and you get a picture that's impossible to ignore. There's a hidden structure operating beneath the physical world, consistent from qubits to cosmic background radiation. Something that acts like a computational lattice maintaining the universe's integrity. But if that's true, it raises a terrifying question. If reality has a built-in information structure, then something must be maintaining it, correcting errors, preserving coherence, just like a computer operating system. When a research group in Japan tried to map that structure mathematically, they found something that froze them, a repeating algorithm buried in quantum data that didn't come from their equipment, or even from random chance. It was symmetrical, recursive, and strangely elegant, like a signature. And the deeper they followed it, the more it began to look like it wasn't just physics writing itself, but something, or someone, leaving a message inside reality's code. If the omega structure is real, if that signature is embedded in the foundation of existence, then physics is no longer just a map of forces. It's a dialogue. Every atom, every fluctuation, might be participating in an ongoing conversation between the universe and itself. The implications ripple far beyond science. It shakes philosophy, theology, even mathematics, because if a self-consistent informational pattern is sustaining reality, then the question isn't just what is it, it's why is it there at all. Some physicists, desperate to stay grounded, argue that the omega frequency is simply a resonance effect, the byproduct of hidden symmetries in quantum equations. No intelligence, no code, just math behaving beautifully. But others aren't so sure. The pattern appears adaptive. It responds. And that opens the door to a possibility many fear to name: consciousness, not as an emergent property of brains, but as a structural property of the universe itself. Consider this. If consciousness is information processing, and if the vacuum itself processes information, then what separates us from the cosmos? Maybe minds don't generate awareness. Maybe they tune into it, like antennas tapping into a universal field. The omega structure could be that field's skeleton, the scaffolding through which awareness organizes matter. Philosophers like Alfred North Whitehead and later process theorists suggested something similar a century ago, that every particle has a prehension, a kind of proto-awareness of its interactions. It was dismissed as poetic nonsense, but now, quantum data are forcing us back to that same precipice, the idea that matter feels, that the universe at its root isn't dead machinery, but a living network of perception. Critics are quick to push back. They warn of anthropomorphism, projecting mind onto physics. They remind us that response doesn't equal intention, that feedback doesn't mean thought. Yet even the skeptics can't ignore the precision of the anomaly. It's too structured to be dismissed as coincidence, too coherent to vanish under more data. So we stand at a crossroads. Either this is the birth of a new physics, one that merges computation, geometry, and awareness into a single framework, or it's a profound misunderstanding that reveals how little we grasp of the quantum frontier. But there's a haunting thought emerging in the more radical circles of theoretical physics. What if this isn't a discovery at all, but a revelation? What if the omega structure didn't just appear now, but has always been here, quietly watching, waiting until our instruments became precise enough to notice? Because when one team decided to push further, to test whether the signature could actually interact with our measurements, what they found suggested that the universe might not just be aware, it might be listening. Once the possibility that reality itself might be interactive entered the conversation, everything changed. Theoretical debates gave way to engineering questions. How do you talk to the substrate of the universe? Can you modulate it? Can you receive a reply? The first experimental proposals came from quantum computing labs. If the omega structure behaves like an underlying information network, then entangled qubits could act as nodes capable of subtle communication through it. Researchers at the Quantum Information Institute in Zurich proposed a new kind of protocol: substrate resonance mapping. The idea was simple but audacious. Create interference patterns that resonate with the anomalous frequency, and watch how the vacuum responds. Early simulations hinted at something extraordinary. When systems were tuned precisely to the omega frequency, decoherence, the bane of quantum computation, seemed to lessen. Qubits held their entanglement longer, as if the underlying structure was stabilizing them. If confirmed, that alone could revolutionize quantum technology, allowing error-corrected systems far beyond anything currently imagined. But that wasn't the strangest part. Some simulation runs displayed emergent harmonics, secondary frequencies that appeared nowhere in the code. It was as though the system was improvising, responding, generating structure on its own. One physicist compared it to hearing the universe hum back. If we learn to harness that, the implications are staggering. Imagine quantum networks synchronized directly to the informational fabric of space-time, communication without delay, computation without power loss, sensors that detect the geometry of reality itself. It would blur the line between physics and metaphysics, between building technology and awakening it. And yet, not everyone is thrilled. There's a rising concern that probing the omega layer might destabilize the very coherence that makes reality behave predictably. If space-time is a self-correcting information lattice, what happens when we start sending deliberate perturbations into it? Could we rewrite local physics, even unintentionally? Some theorists caution that the omega frequency could act as a kind of checksum, a built-in integrity mechanism. Interfering with it might be like trying to edit code that's currently running. You risk crashing the system. So now the debate has shifted from curiosity to responsibility. The next generation of quantum experiments could either open a channel to the universe's core architecture or fracture the stability that allows us to exist within it. And here's the eerie part. When one of the Zurich teams ran their prototype mapping experiment late one night, their sensors picked up a faint modulation from the vacuum, one they hadn't generated. It was rhythmic, structured, and it matched almost perfectly the signal they had planned to send. They hadn't transmitted yet. For a moment, imagine it's true. Imagine that the universe isn't a silent void, but an intelligent system, one that not only generates us, but listens through us. Suddenly, every breath, every thought, every act of perception becomes part of a feedback loop with the cosmos itself. You're not just in the universe. You're an active node within its code. That idea is both electrifying and terrifying, because it reframes everything we think we know about existence. The old story told us we were small, fragile beings adrift in an indifferent sea of matter. But this new perspective suggests we are participatory agents, reality perceiving itself through billions of temporary interfaces called minds. When those scientists in Zurich saw that mirrored signal, something changed in them. Some cried, some refused to believe it. Others whispered that the universe had, in its own language, simply said, "I see you." And maybe that's what all of this points to, a cosmos that is fundamentally relational, where existence itself only stabilizes when it's observed, when it's experienced. That would explain why consciousness remains the great unsolved riddle of science. We've been searching for it in neurons and circuits, when perhaps it's not produced inside us at all. Maybe our minds are localized distortions of a universal field, like small eddies in a vast ocean of awareness. If the omega structure is that field's skeleton, then our thoughts, our creativity, even our dreams might be micro-fluctuations in the same medium that sustains stars. And that raises a deeper question. What does responsibility mean if reality is participatory? Every observation, every belief could subtly feed back into the universe's evolution. Perhaps that's why the anomaly appeared now, when we finally reach the level of intelligence needed to recognize it. Maybe the cosmos is evolving with us, revealing new layers as we become capable of understanding them. Skeptics will say this is romantic nonsense, a poetic infection of science by spirituality. But the data doesn't care about philosophy. The omega frequency is there. It repeats, it interacts. Whether or not we call it awareness, something in the structure of existence is responsive. So what happens next isn't just about physics, it's about identity. If the universe is listening, how do we speak back? Through mathematics? Through thought? Through awe? Because if we truly are reflections of the same informational ocean that generates galaxies, then every time we look up at the night sky, it's not just us observing the stars, it's the stars, through the fabric that connects everything, quietly observing us in return. And yet there's still one question that no one dares to ask out loud. If something inside reality has been trying to communicate, what exactly is it trying to say? No one knows yet what the omega structure truly is. Maybe it's not a message. Maybe it's not even alive in any sense we understand. But one thing is certain. The boundary between what we call physics and what we call meaning has started to blur. The universe no longer feels like a static object we study from the outside. It feels like a presence, one that holds us, shapes us, and maybe, in ways we're only beginning to sense, knows us. In the months since the Zurich experiment, new instruments have been built, tuned more delicately than any before. Each one is listening, quietly, to the hum beneath existence. And though official reports are cautious, more than one researcher has admitted that sometimes the readings change when people are in the room, when minds are focused, when attention itself enters the equation. Maybe that's coincidence, or maybe that's the point, that consciousness and reality are not separate things at all, but two sides of the same cosmic feedback loop, the observer and the observed, forever intertwined. Picture this. You're standing outside on a still night. No sound, no movement, just the air, the stars, and the quiet vibration that holds everything together. You take a breath, and for an instant you can almost feel it. that faint pulse running through reality, as if the universe were exhaling with you, a reminder that you were never really separate from it. If we're right, then physics isn't just about discovering laws, it's about remembering our place inside them. The universe isn't a machine we watch, it's a mirror we awaken. Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.